the trees Kahoot. Question 7. When comparing an AVL tree and a BS binary search tree, which would be considered more efficient and why? So the answer to this would be an AVL tree, as all of its main functions are over login. And let's take a look at just the search function, as it is illustrative and it is what the insert and delete functions are in some manner based on. So here you have a binary search tree, and here you have a AVL tree. So with an AVL tree, of course, you know it's always self-balancing, so it has the minimum number of levels needed. In a binary search tree, the only property it has is that the left child is less than the root than the parent, and the right child is greater than the parent. So here, let's say you wanted to find number 4. You would go down one level. That cuts down the things you have to look at by 1. You go down another level. That cuts it down again by 1, and then you cut it down to 4. Now that cuts what you're looking at in half. So now you've taken 3 steps to find 4, which is not terrible, but you can see how in a more complex binary search tree that is even more unbalanced, it may be unwieldy, and it may start to approach the degenerate case where the binary search tree is in some effect a linked list. Now with an AVL tree, that is not an issue, because given that it's self-balancing, you're always going to cut the number of nodes you're going to look at in half. So let's say you want to find 4 in the AVL tree. You start at 5. You know that 4 is less than 5, so you go down 1. Now you've cut all of this off. You've cut about half. Now from 3, you know 4 is greater than 3, so you go down 1. So you've cut about half. And now you find what you're looking for in 2 steps as opposed to 3. And of course, it's always going to be in the most efficient number of steps. Well, it's going to be in log n steps because each time you cut what you're looking at in half. Are there a number of things you can look at in half? Yeah. AVLs are more efficient. They are binary search trees made better.